Previously on Looking at Things Curiously on the Museum of Everything Else YouTube channel.
I sort of got that right. That was pretty bad. We looked at the May 1976 Everyday Electronics. And in this, it said about next month. We've got next month wah-wah pedals, enlarger meters, continuity testers, peak level indicators, all of this stuff. And I did say at the end of the last video that I was going to try and find June 1976. And lo and behold, with a little bit of luck, well, it's right here. Boom! Everyday Electronics, June 1976. So as you can see, we've got a colour picture of a funky band. 3 of them in the band, looking pretty funky. Singer on guitar, bass guitarist, nothing much has changed. Enlarger meter, and then a continuity tester, and it looks like it's testing, and it looks like it's testing the peak level indicator. Oh no, the peak level indicator is right there. So I guess those two are in the thing. Anyway, without further ado, let's have a look on the inside. So let's flip over and see what we have. Oh, there's another. This is similar. There's going to be a lot of similarities to a lot of these magazines. Not every week is a magazine, by the way. So we'll just like, as you know, I'm fairly well in with the managing director of Home Radio Components Limited. He was deep in thought when I called him the other day, cooking up something new. I said, "Yes," he replied. "I was thinking of giving a piece of Veriboard to everybody who buys one of our catalogues. Ooh, but I'm wondering if the idea is a bit gimmicky." "Certainly not," I assured him. "Several electronic magazines have done it before, and I'm sure lots of customers appreciate it." Encouraged, he went on, "I thought that if I offered 4 projects for which the board could be used, it would make it even more useful and interesting." That set the ball rolling. And with the cooperation of Vero Electronics Limited, which is actually where Veriboard came from. It's funny because I found out later, I found out in the last thing, I didn't know this, correct me if this is wrong, but I'm guessing Vero Electronics is sort of like the Hoover of prototyping boards. So Veriboard is named after Vero Electronics Limited, and of Mr. Fred Bennett, editor of Practical Electronics. He is now able to make this unique offer. To every purchaser of a home radio components catalogue will be sent a piece of Veriboard. That's pretty cool. So get a load of that, take a screenshot, send that over to 234 London Road, Mitcham in Surrey, CR4 3HD. You never know, there might still be some available. Oh, shall I just do that? Maybe one of these videos I will actually cut one of these out and just post it and see what happens. That'll be pretty good. Okay, we got similar vibe to the last time. In fact, this was in the last one, and it's gone up in money. It has gone up in money. If you remember last time, I think it was closer to £13 in the old one. In fact, really quickly, let's just see. This was only a month's different. Look, £12.48. Special offer. Special offer, there we go. And yeah, £14, including that. Well, it was worked out in the last video because the comments. This is about £100 for this kit. So yeah, complete built kit. So that's the built kit. Okay, that makes a bit more sense. Oh yeah. Anyway. Got some good stuff. We're still at the start where there is a lot of promotion on different shops and stuff. Check out that. That's pretty cool. Over at Henry's Radio Video Sport, an up to the minute game plugs into your aerial socket, switch on, and you're away. Choose your game, football, tennis, or hole in the wall. Absolutely safe for you, your children, and your TV. Mains powered, listed price £42.50. Henry's price £25. So yeah, that's not a bad price. So if you want one of those, go over to Henry's. Henry's is based on Edgware Road in London, 303. In fact, I think that might still be... Nah, surely it wouldn't be. I just recognised... So I remember there was an old electronic shop on Edgware Road somewhere. So maybe. Everyday Electronics. Projects easy to construct, theory simply explained. Take a tray. There are dreams and then there are realities. No matter how far we got carried away with the one, we have eventually to wake up and face the other. For instance, it is of course very nice to have a workshop for one's own use. A room or garden shed where one can retreat and concentrate entirely on one's hobby. A separate workshop or workroom gives privacy and allows one to depart at any time, leaving things just as they are in confident knowledge that they will remain so until the owner's return. And a workroom will accommodate all the equipment the average electronics constructor is ever likely to require, without crowding but laid out for maximum convenience. But the fact is, this ideal kind of arrangement is just not possible for many people. Perhaps the greater proportion of those who enjoy working with electronics in their leisure hours, alternative arrangements have to be made in the majority of households, where the luxury of exclusive premises for one member of the family to indulge his or her favourite pastime is entirely out of the question. Fortunately, electronics is itself very accommodating. Demands for storage space can be minimal. Useful stock of components can be contained within a shoebox, while the essential tools will not fill another. Add a multimeter and the basic stock in trade of a home constructor is all accounted for. As for working area, any flat surface will serve as a bench. So never postpone actual construction activities until the ideal situation materializes. Find a quiet corner in any room, take a seat, place a tray, wood or plastic, in brackets, on the knees, and work can commence. That's true. See, I may as well read to the end. Newcomers should note that this informal, comfortable posture is adopted as normal procedure by quite seasoned constructors, brackets, and not infrequently by choice. All normal circuit assembly work can be performed in this homely fashion. If you prefer to sit at the table, a tray is still a good idea. Apart from protecting the tabletop, it means that one can readily pick it up and carry away all the bits and pieces at a moment's notice. Beating a hasty retreat in one maneuver, the family constructor must be prepared for. Our message is therefore this: nothing need deter the beginner from getting started, though we can all dream about a wonderful, well-equipped workshop of our own. There's no need at all to hold back until that dream materializes. Start in a modest way we have described and enjoy the fun and the practical achievements which come from being immersed in tabletop technology. P.S. Oh, do mind where you put that soldering iron. An oven tin will make a suitable space, safe depository. Just not in the kitchen, possibly. I mean, in the kitchen is fine for me, but it's probably not fine for everybody. Right, anyway, we got to get looking. So we got the wah-wah pedal starting up. That's a pretty cool picture. Cool fellow right there. By B.W. Terrell. Wonder if anybody knows them. BSC. As you can see, it's just a pretty simple filter, basically. There's the pedal, which is the VR, and then it's around a 741, but you could use any op amp, really. But this is via 9-volt battery. So if you want to make a super simple 9-volt wah pedal, then this is your pal. Maybe we should build it one day. I keep on saying maybe because, like, if I build it now, I'm not going to get to the end of the thing. So just check it out here, how it works. Let's have a read. This is the interesting bit. Basically, the wah-wah pedal is an amplifier, but it only amplifies signals with frequencies within a fairly narrow band and attenuates signals with a frequencies outside this band. The amount of attenuation increasing with the distance from the band limits. The position of this frequency band in the unit can be changed by varying a single component, the potentiometer, which is mechanically linked to the pedal. Moving the pedal causes the band to sweep up and down, and when the signal from an electric guitar, for example, are injected, produces the familiar wah-wah sound effect. That's pretty cool. So yeah, and then it's got the more practical thing. It's the same thing as last time with the they've been a little bit lazy on drawing the circles, but maybe that's for clarity here. It looks quite simple. You don't need these massive capacitors nowadays. You could literally get away with modern style capacitors. So these big ones and even smaller resistors, you don't need that. Just go on face value of what they are. Like that 100 microfarad one could be, you know, just like a standard 100 microfarad. Any of them, as long as it's over the 9-volt limit, you can be fine. And as for the 100Ks, any 100Ks or any resistors would really work. Even very low watt ones should still be fine. And all, yeah, just standard things. Chuck it together. Let us know if you've made it. And here's a strip board layout. However, it's just such a simple thing that I would suggest to just build it and try it. But like, it's got little cuts. These are the slices in the strip board, and I guess these two are in between these bits. I don't know what these two... Oh, that's for the fixing hole, to isolate these parts from that fixing hole. So you don't need to bother with this if you're not bothering putting a fixing hole there. Maybe you can have a little bit of a larger bit of variable and have the fixing hole up there. And as for these four, that goes directly underneath the op amp to stop this side of the op amp conducting to that side of the op amp. And then there's the components over here. It's looking pretty snazzy. Oh, and the estimated cost is £2.70. And funnily enough, with all of the prices in like talking new prices in a shop like Rapid Electronics or something, or Mouser or wherever you're based, that would probably cost about £2.70. Again, probably not the pedal case. The pedal case is pretty cool though. That's really cool. So the pedal case is actually, you can sort of notice it if you look closely. You can see that like it's been sanded a little bit loosely, but it's actually it's a plywood case. The pedal and case of the prototype were made from plywood and chipboard to the sizes shown in figure 4. Figure 4 is not. Figure 4. Yeah, these are the exact sizes. How cool is that? It's not to scale. It's not to scale, I must add, on this picture. So you could probably make this with those sizes. So like I said last time, this is in 4K. If you want a screenshot, if it doesn't look clear, set your YouTube to 4K and then take a screenshot and build away. Build like crazy. It looks like it's got some Meccano parts in there. In fact, let's have a quick look. It says glued together. All components nailed and glued together. When the case has been fabricated, the cutouts and holes should be made in the sloping panel to accommodate the pivot bracket fixings. Oh, look at this! Look at that! It's all Meccano. The components, boards, fixing bolts. Next, the aluminium bracket for securing VR1. Looks like that one, maybe. Yeah, that's where the potentiometer goes. Should be made and fitted in position. The bolts fixing this to the side of the case should be countersunk types, of course, for the need of finish. Meccano parts have been used to produce the linkage and pivot, and details of these are given in figure 5, which is right here, so get a screenshot of this stuff. Likewise, I probably will have found a copy of this on the internet, like a PDF of this, and I will link it below. All in all, that's pretty awesome. Just the fact that, they've just said, just use your kid's Meccano. They'll be like, Dad, I can't build my car. It's all got missing parts. Oh no, Dad. Oh, don't worry, son. I'm just playing my guitar. Go away. That's him playing it with a wah-wah pedal. It doesn't really make much sense. Anyway, we're going to skip over to the next one in a hasty fashion. Over to the Enlarger meter. This Enlarger meter is designed to eliminate the need for test strips in determining the exposure time required for making an enlargement. The instrument has a range of approximately 4 to 40 seconds, which should cover most needs in the amateur's darkroom. I was initially thinking it was going to be similar to last week's the lightning chess buzzer, which was a timer that is just packaged as a chess timer, a lightning chess timer. The circuit of the instrument is shown in figure 1. That is not figure 1. Figure 1's right there, so take a little peek at that first before we read on. As you can see, yeah, it's a op amp set as a comparator. It's pretty funny. So yeah, the 741 operational amplifier is connected without any feedback, so it amplifies the voltage between its input terminals, pin 2 and 3, about 200,000 times. Any small voltage difference between the input terminals greater than a few millivolts will therefore cause the output to swing to either 0 volts or 9 volts, i.e. the voltage limits determined by the voltage supply, the power supply, your battery. A potential divider... Oh, sorry, I've just lost myself. A potential divider is formed by resistor R3 and light-dependent resistor PCC1, as you can see there. So this R3's up there, and so there's a voltage divider, and that's the it's like a light-dependent resistor. Yeah, it's just the bit you put your hand over and it goes woo, woo, woo. Which in turn is dependent on the amount of light incident on its face. Varying the position of the wiper of VR1 will bring the voltage at pin 3 of IC1 equal to that at pin 2. At this point, the light emitting diode D1 will go from on to off, or vice versa. By using a calibrated scale on the potentiometer, VR1, which is... where's the VR1? So yeah, this one I guess goes on the front. The on-off position can be used as a measure of the amount of light falling on the light-dependent resistor. I've got to be honest, I should probably ask Mel, my partner, because she will have a clue about what this is used for. I'm trying to understand how this relates to seconds. Very strange. Interesting. Maybe somebody can shed some light on this beast. Anyway, if you want to build yourself an Enlarger meter, it's thoroughly simple. Oh, so we're already on next month and we're not even halfway. So let's have a look at what we're going to expect next month, and I'll see if I can find next week. We've got an auto cooler. Keep your car engine cool in hot weather and in traffic jams by fitting this easy to construct thermostatic unit. Interesting. Looks like a dodgy Ford Capri, maybe? Don't know what that is. That a Capri looking? Looks like either between a Capri and an Interceptor. Yeah, maybe a Jensen Interceptor, maybe. It's too round for like a scimitar. I don't know. What do you reckon that car is? Accented metronome. An aid for musicians, produced an audible click that present a preset tempo and can be set to emphasize the second, third or fourth beats in the bar. That's pretty cool. That'll be good because it'll have a divider circuit in it or something like that. An RF AF signal generator, and the AquaGuard, a multi-purpose detector for many applications in the home laboratory and afloat. I have no idea what the AquaGuard is going to be, but it's we're going to be full of surprises, and that's in the July issue. So if I can find July 1976, we are going to be golden because I will have a look. I might have it. I probably will. We'll see. A little bit of your electronics. Here we go. The electronic instrument industry. A career in electronics is an exciting prospect. Month by month, our contributor, Peter Verwig, explains that working in electronics is all about how to prepare yourself for a rewarding career and the job opportunities available in the world's fastest growing industry. Yeah. I'm going to choose something at my... Oh, here's an interesting one. Hewlett-Packard. We have chosen Hewlett-Packard as our model company for describing a career in the instrument industry. The history of Hewlett-Packard is a classical example of modern enterprise. The story starts in 1939, when two young and bright university graduates, Bill Hewlett and Dave Packard, decide to go to alone. Their first premises were the garage at Packard's home in California. Their capital, a borrowed $500. Whoa! That is insane. £100 is $500 at 1939 exchange rates. Anyway, their first product, a new type of audio oscillator. Today, HP, still headed by Bill and Dave, has an annual turnover of more than $1 billion. 500 million pounds. So it's like in 1976 the exchange rate was like $1 is a half a pound basically. Over 3,400 different products, a worldwide payroll of more than 30,000 people, and manufacturing plants in the USA, Brazil, France, West Germany, Japan, Malaysia, Singapore, and the United Kingdom. The historic product base of test and measuring instruments has been expanded to include medical electronics and analytical experimental instrumentation. And together, these product categories represent 60% of Hewlett-Packard's business. The remainder is mainly in electronic data products, a category which includes MIDI computers and desk and pocket calculators. HP has always been a high-technology company, concentrating on performance and quality rather than price. Oh, you're losing it. To keep ahead in technology, HP employs 2,000 scientists and engineers on research and development, R&D. And last year's R&D expenditure was nearly $90 million. £45 million. Oh, here we go. HP in the UK. This is going to be interesting. Hewlett-Packard is thus a multinational corporation producing world-class products for the worldwide sale in the United Kingdom. Hewlett-Packard Limited has its headquarters at Winnersh, near Wokingham, Berkshire, and a large manufacturing plant in South Queensferry, on the Firth of Forth, near Edinburgh. The Scottish plant currently employs some 700 people, and the administrative and marketing department at Winnersh have 450. In all but ultimate ownership, the UK operation is British, with British management and British capital, operating profits being ploughed back into further expansion. But as well as being a British and European offshoot of HP Corporation, the UK HP Limited is an important contributing operation both technically and economically to HP. On a world scale, because it is the only design and manufacturing centre in HP for telecommunications instrumentation. The laboratories employ 80 engineers designing instruments for worldwide sale. This year's budget is £750,000. South Queensferry also manufactures all the home-designed products, and these account for 40% of total production. The remaining production is mainly of HP products like signal generators and frequency counters. For sale in Europe, altogether, some 85% of production is exported. Getting started. As you may have already gathered, HP Limited is a top-class company for top-class people. All sales engineers, for example, are university graduates who really know instrumentation and the customer's own measurement problems. The same applies to R&D staff, technician grades, joining young and encouraged to study for the HNC. HP is, in fact, a great believer in career development. And one of the reasons why it is hard to get in is because very few people leave, and consequently staff turnover is very low compared with most companies. A young person joining as a technician might work his or her way up through testing to a production supervisor, or by the late 20s be sufficiently experienced to move out to field service based on headquarters or one of the branch service centres. How does HP hold on to its staff? Certainly not by pay alone. HP claim only to be competitive in salaries, but there is a profit-sharing bonus which comes twice a year. The hold on staff seems to come more from job satisfaction and working condition. There is no distinction between people, everybody being on a monthly salary with no hourly or weekly paid workers. At South Queensferry, the working week is 39 hours on a flexi-time system. People choosing their own starting time between 7 a.m. and 8:30 a.m. so that those who like to get home early can do so if they wish. Oh, how progressive! Self-motivation is encouraged, and there is little of the soul-destroying repetitive work associated with conveyor belts and mass production. A skilled assembler doesn't solder in a few components and pass the instrument up the line, far more likely to assemble the whole instrument, taking up to 40 hours to do it. I mean, that's pretty hench. So, let me know if you were one of those. Quality instruments are made in comparatively small batches, so there are frequent changes of product, which itself creates variety and interest. Instrument manufacturers are not all like Hewlett-Packard. Many have different methods of work, different staff conditions, different product lines, but nearly all have a lot in common, except for manufacturers of the very cheapest instruments. Most work on small batch assembly principles which make for variety. And all to stay in business need to strive technically for advances in performance and accuracy. A career in instruments is a lively and fruitful occupation. It's just entering a new phase of technical development, so is full of interest. And in the long term can be a career for life. For life. For life. And there we go. That's a career for life right there. Doing some testing of what looks to be... Ooh. Is that a cigarette? Oh no, I thought it was a cigarette. Just calibrating some sort of device. Maybe it's an oscilloscope. It's got a lot of wires popping out of it right now, but it's pretty funky. There looks like a data recorder in there. Pretty cool, pretty funky. So it has got a whole bit on ICs Explained. However, I didn't read part 1 of it, which was on the last magazine, the last one. So if you're interested in that, I thoroughly recommend using the links, which are hopefully going to be below, to check this out, because it talks about the last one. Oh, shucks. The last one talked about manufacturing of them back in the 70s, and this one looks like it's just talking about different packages. Even this one with a funky heat connection thing. Very funky indeed. A magnified view of the National Semiconductor LM1812 chip. A complete MOS RAM 104. Random access memory produced by National Semiconductor. That's bloody huge. And this is, you've got to remember, this is 1976. So, yeah, pretty amazing. A bit more of a beefy circuit. That looks pretty damn awesome. It seems to have 2 inputs. It's a stereo one, it seems. That's interesting. So I guess these two light up when it's peaked. Wonder if there's an adjustment. Yeah, there's adjustments as well. So let's read about it. The peak level indicator described here is suitable for use as a fast responding overload indicator in amplifiers and tape recorders, where it will give a visually indication of fast transients normally missed by the slower responding VU meters. Oh, potentially adds a tail to them as well, like because there's got big old chunky capacitors. The circuit of the complete stereo peak level indicator is shown in figure 1. I'll zoom in a little bit. Resistor R1 right there and Xenodiode D1 produce a stabilized 6.2 volts at their junction, which is used to feed both circuits. Apart from these components, the rest of the unit consists of 2 identical circuits, one for the left channel and one for the right. Lovely. Resistor R2 and R4, which are right here, R2 and R4, lovely, form a potential divider, which set a fixed bias voltage at the inverting input, number 2. Of IC1. Resistor R3, which is this one right here, and potentiometer VR1 form another potential divider which enables a variable voltage to be applied to the non-inverting input, which is right here. Under no input condition, the inverting input will be at a higher voltage than the non-inverting input. The amplifying action of the operational amplifier, right there, will cause the output pin 6 to drop to almost 0 volts, since the capacitor, C2, right there, is connected to the junction of the potential divider, right there. There will be a voltage across it of a couple of volts. This will be in such a sense as to have the non-inverting end at a higher potential than the output end. If a signal is now applied to the input, right there, the voltage at the inverting input will vary in sympathy. That's a pretty interesting description. Positive voltage swings will not affect the output, simply tending to drive the output nearer 0 volts. Negative swings, however, will cause the voltage at pin 2, right here, to fall below that at pin 3, which will cause the output to go towards 9 volts. 9 volts, it's got the battery right there, battery. As the voltage across the capacitor cannot change instantaneously, the voltage at pin 3 rises well above the voltage at pin 2, thus keeping the output voltage high until the charge on the capacitor has decayed to the same level as the inverting input. When the output falls to its previous low level, hence, the output stays at this level until the capacitor charge has recovered, at which time the circuit can be de-triggered again. When the output of the operational amplifier is high, the light-emitting diode D2 is illuminated. Resistor R5 serving to limit the current. So I guess, yeah, the R5 is lit up until see, the capacitor loses its kaflunk. So yeah, it's just a peak level indicator, and you could probably use this circuit right here in your synthesizer. The circuits, yet again, it's got a nice, this one's in a nice enclosure, but my favourite part of all of this is the 1970s futuristic font, the left and the right. Oh, you don't see that much anymore, that kind of font. It's awesome. It's awesome. Sound design, a practical electronics publication. Okay, I'm writing down that. I'm going to see if I can find that on eBay. Sound designs publication. Sound designs. Oh, it's a very bright red. Maybe it's the light I've got. The Minisonic Mark II. Oh, I'm writing down that as well. Minisonic Mark II. Sound synthesizer, an updated version of the published Mark I. The Mark II has an integral keyboard. Oh, that's friggin' awesome. 250 milliwatt monitor channels and loudspeakers. It's got loudspeakers in it and facilitates for amplitude, frequency and harmonic modulation. I tell you what, it's really funny. It's like, what is so exciting about the same old monophonic subtractive synthesizer just being plonked in a different looking square box? I don't know why, but it just really excites me when I just see one with just all of that. Look, it's just the same as any other. 2 oscillators maybe. Those are the, maybe. There's a bunch of preset buttons that look a little confusing. They look a little bit like the push and the eliminate ones. It's a little bit interesting, but available now for £1.20. To be honest, I may be tempted to send this off and just see if it actually comes back. Kingsreach Tower, Stamford Street, London, Southeast 1 9LS. And send it £1.20. Obviously, it's just what does it come with? The Joanna electric piano has realistic piano effects. Oh, realistic piano effects. That's what we all want. With touch-sensitive keyboard and additional choice of harpsichord or honky-tonk voicing. Of course, that is very important. And the Orion stereo amplifier, as well as some great sound effects units for guitars, keyboard instruments, and general recording. That's pretty cool. Yeah, maybe track one of those mini Sonics down, but that it just looks really cool. The continuity tester, lovely jubbly. You'll recognise something here. So this continuity tester is extremely simple, and it's got a transistor. They call it it's a relaxation oscillator feeding a miniature speaker. So you just literally got a speaker, and this is their oscillator in there. So it's literally an oscillator. I guess you can adjust the pitch of this oscillator with that. So the continuity tester will get continuity when this part of the circuit is complete. So it's literally those 4 components and a battery if you want to make your own continuity tester. The transistor that they have here is a T1S43, and it's £1.20. Very simple. Look at that beauty. Oh, look at that. Oh, I love it. I love the effort that's gone in. Like, look at the little grill. They've used a little bit of perforated, like that grill stuff plopped in. Oh, and if you can tell really closely, looks like a Boots battery. Looks like it's got a Boots logo on it. It's pretty cool. Oh, our favourite. Our favourite is back again. The extraordinary experiments of Professor Ernest Evershaw. Bob was bursting to know what was inside the mysterious boxes, each the size of a large biscuit tin, and with 2 wires, one red and one black, protruding from a hole in one side. One after another, the robot connected each box to the voltage breakdown tester and appeared to be testing each box in turn. 1 or 2 things about this procedure were very puzzling to Bob. First, Bob was puzzled by the voltage readings the robot was obtaining from the multimeter, as the voltage across each box did not rise smoothly, but appears to rise in a series of jerky movements of the multimeter needle. What kind of components could be reacting like this, Bob wondered. The second puzzling thing was, why did the robot repeat the test several times with each box going through all the boxes one after another, then starting with the first? Surely, Bob thought, 1 test should be enough. But as he saw the robot connect one of the boxes once again to the tester, Bob thought in exasperation, I'm sure I've seen him test that one 3 or 4 times already. However, Bob continued, with the work of constructing a random noise generator in accordance with the circuit which the prof had drawn out, designed to take advantage of the very efficient noise generating properties of a reversed biased light emitting diode. Ooh, that sounds funky. Soon, Bob had completed the noise generator, and he decided to test it. First, he connected the output of the generator to the input of an audio amplifier, and as he gradually turned up the volume, a hissing sound came from the loudspeaker. As Bob adjusted the tone controls, he found he could vary the sound from a low roaring to a high, sharp hiss. This is because the random output generated by this circuit contains all the frequencies in the audio range. The prof, who had returned and was observing as Bob made these simple tests, informed him it also contains frequencies outside the audio range, above and below the ranges of frequencies which we can hear. There are a number of interesting experiments which can be performed using the random generated frequencies within the audible regions and other experiments which will demonstrate frequencies both above and below the limits of human hearing. The types of sound effects you were producing just now, Bob, by adjusting the controls on the amplifier, can be made even more striking by using tone filters of various types than the tone controls. On an audio amplifier, the Prof informed, the Prof produced a number of books on the subject of electronic organs, and quickly flipping through the pages soon found a number of circuits for production of various synthesized organs and instrumental tones. "Hey, Prof, some of those circuits look really simple," remarked Bob, as he examined a few pages which were covered with small circuit diagrams. Tone filters. Each diagram was marked with the name of a different musical instrument. Organ, flute, horn, clarinet, etc. Yes, the Prof agreed. In most electronic circuits, the tone filter circuits are indeed simple. Only a few components are needed to produce the tone of each instrument. Although the electronic organ itself may be quite a complicated piece of equipment, some of the simple circuits which are used in it may be built and used separately, and this is quite easy to do. It can also be very interesting. I have already built a number of these tone filter circuits, and their effect is quite different from the effect of tone controls in an audio amplifier. The Prof is one here. The Prof showed Bob a number of experimental tone filters which he had built. Some of these were built in accordance with the circuits in the Prof's reference books, whilst others had been modified by the Prof. During the course of his experimentation, each of these tone filters has been designed for the processing of a particular waveform. The Prof informed Bob usually sawtooth, square wave or pulse wave forms. However, they can be used to filter random noise quite successfully, and most of them can be connected directly to the output of your random noise generator. Modular synthesizer, here we come. Bob connected a number of the tone filters to the output of his random noise generator, one at a time, connecting the output of each filter to the input of the audio amplifier. And in this way he could observe the audible effects of each filter of the sound produced. The results were a remarkable series of sound effects, and as Bob was about to connect one particular filter, the Prof stopped him. "This is a low-pass filter, Bob, and it will only allow the extreme bass frequencies to pass. So in order to hear the effect of this particular filter, an amplifier and speaker should be used which are capable of responding well to bass frequencies. And I have an amplifier here which will suit this purpose better. It is connected to a larger loudspeaker." Whoa. The Prof connected the output of the low-pass filter to the input of the bass amplifier, and as he very carefully adjusted the volume control, an ominous rumbling sound came from the loudspeaker. Removing the front grille from in front of the speaker, he showed Bob the speaker cone, which, instead of making the regular movements associated with a steady note or frequency, appeared to be moving in an unparticular and predictable way. On a nearby oscilloscope, which the Prof had connected to the amplifier, the slow-moving spot on the screen appeared to mimic the movements of the speaker, leaving a series of irregular, humpy lines on the long, persistent screen. If we use a low-pass filter with even larger capacitors, the Prof informed Bob, this will cut the audible frequencies down to an imperceptible level. We would be unable to hear those frequencies if they were fed into a loudspeaker, but powerful vibrations can be produced in this way, and because we cannot hear them, it could be quite dangerous to health. Oh dear. The random noise generator is really interesting, Prof, especially when we can hear all those sound effects through the audio filters. But this low-frequency random noise, which we cannot hear, also seems quite interesting. But what puzzles me is, whatever could it be used for? Robot tester. If the very low-frequency random noise is fed to a cathode ray tube, it can be made to move the spot on the screen up and down, from side to side at random. Aircraft pilots are tested on a device like this. The pilot sits at the controls of the tester, and these may be arranged to resemble aircraft controls. By using these controls, he can move the spot on the screen up and down from side to side at will until the random frequency is switched on. The spot on the screen then begins to move at random. The pilot must use his controls to keep it in the middle. of the screen, and this can be quite a difficult test. On the screen are a number of circles, like a bullseye target, and if the pilot allows the spot to move outside of one of those circles as a buzzer sound. Oh dear. Here, Bob! The prof led Bob to another part of the laboratory, where he could see a number of the experimental seats fitted with steering controls. This sounds like an awesome laboratory if he's got like aeroplane testing places. And facing each one, a simulator control panel and a display screen. Nearby were a variety of other test settings and partly built experimental robots. This part of the laboratory is being used as a robot testing station at present, and some of the equipment which I use for testing experimental robots is very similar to the equipment used for testing spacecraft pilots. Bob could see that one of the robot testers looked very much like a spacecraft atmosphere re-entry capsule with pilots and controls and a view screen. This one uses low-frequency random noise generators to simulate perturbations in a trajectory, and the pilot being tested must be able to correct these and maintain a correct path. Here, Bob, Prof invited, get into the pilot's seat. As Bob climbed into the pilot's seat, the prof strapped himself into the co-pilot's seat beside him and advised Bob to fasten his seatbelt as the tester could move unexpectedly. Under the influence of the randomly generated perturbations, these could cause it to tilt, sway, roll, or turn in various ways. In response to random signals, the pilot's response or a taped or computer-generated test program, as the professor pressed a few buttons on the control panel, a number of dots appeared on the view screen. All the dots were fixed in position, except one which could be moved by means of the controls. The prof showed Bob how the movements of this dot could be controlled from side to side by means of rudder pedals and up and down by a movable joystick. Oh, what's that? Figure 1. Oscilloscope vertical and horizontal positions control. Varies depending on a voltage. Interesting. Bob could see how the remaining 6 dots could be joined up like a 7-segment calculator, displayed to produce any numerical, and anticipated the test the professor was about to test him. That looks really easy, he thought to himself. I know how the horizontal and vertical shift controls work on an electrostatic deflection cathode. Oh, this is a long one. This is longer than last month. Cathode ray tube. A picture of the basic circuit for these controls came before Bob's mind. Figure 1. Oh yeah, that was that picture. Now, if the horizontal shift potentiometer is connected to the rudder pedals and the vertical shift potentiometer is fitted to the joystick, it should be quite easy, thought Bob, to steer the moving dot from point to point. Meanwhile, the prof had made further adjustments, and wherever the bluey-green moving dot went, it left behind it a glowing yellow trail. Ooh, that's pretty cool. Just to familiarize yourself with these controls, Bob, the prof suggested, try using the moving dot to join the 6 stationary dots in order to form any number you wish. I would suggest that you try a fairly simple one, as these controls are quite tricky. To his surprise, Bob soon found that he had considerable difficulty in getting the moving spot to spot over the first dot. The reason for this being that the controls were indeed, as the prof warned him, somewhat tricky. Whilst Prof was making his adjustments to the control panel, he had, unknown to Bob, craftily reversed the controls by means of changeover switches, so that as Bob moved the controls, the spot moved in a direction opposite to what he expected, up instead of down, left instead of right. Worse still, the controls also had a delayed action effect. Oh, that sounds awful. When Bob tried to steer the spot towards one of the dots, it first of all went in completely the opposite direction. Then, when he moved the controls the other way, he found that the spot did not respond instantly. The delayed action circuit caused it to respond shortly afterwards. so that at first the spot appeared hardly to move. Then it gathered speed, and before Bob could stop it, it had moved right past the place he was aiming for. Bob's first few attempts produced a series of wild squiggles on the view screen, and whilst the prof shook and chuckled in the co-pilot seat, Bob, who was determined to beat the challenge, doggedly struggled with fierce concentration with the tricky controls until he had mastered them sufficiently to produce a series of numbers on the screen. As Bob triumphantly finished off an almost perfect figure of 8 on the view screen, the prof leaned across with a grin and tapped Bob's shoulder. "Are you ready to try it with the random noise generator yet, Bob?" he asked. "Yes, Prof. I feel ready to try that, but first I'd really like you to explain to me, how does the delayed action circuit on this gadget work? Could an attachment be easily built to enable me to do this with an ordinary oscilloscope or a TV set? The basic circuit for use with an oscilloscope is quite simple," Bob explained to Prof.
Continued next month.
Definitely got to find next month's Rick and Morty of the 1970s. It's pretty damn interesting. As we go through, there are a lot more just basically shops. This is a
J. Bull Electronics Limited in 103 Tamworth Road, Croydon, CR01XX.
You could get your thermostat, get your centrifugal fan, ammeters, you name it. You can get it here. Light pipe. Ooh, pretty funky. What's that? Learn in your sleep. Have a radio playing and kettle boiling as you awake. Switch on lights to ward off. That is pretty funny. A timer for when you... Neon tube. A beautifully simple relaxation oscillator is the neon tube oscillator. Funnily enough, there's a if you check out Fran Labs, there's a recent video on Fran Lab she made a Christmas tree with neon tube oscillators. Pretty awesome, and there's the schematic of it. So you can make that neon tube flash. So I'll read it. So this works because a neon tube has the property that it doesn't strike until a high voltage is applied, but then as soon as it strikes, the voltage across it falls to a lowish value. When the circuit is switched on, there is no voltage across the neon because the neon gets its voltage from the charge on C1. With the circuit off, C1 is uncharged. Switch on and C1 charges via R1. Right there. No current flows through the neon until C1 is charged to say 100 volts. So that's then the neon strikes and passes the current, and since R2 is much smaller than R1, the charge on C1 is rapidly drained away until the voltage on C1 falls to 80 volts, at which point the neon goes out, it turns off again, and the cycle recommences, making a neon tube oscillator. I've never built one myself, and it looks really interesting on the Fran Lab video. Cost of projects. In the past, we have had complaints from some readers about the high cost of some of our projects. After all, they say many of our readers are still at school or college and have a very limited income. We have always tried to keep a balance when publishing an amplifier or receiver that carries a high price tag, but this month, although all the projects are excellent and useful, none of them cost more than £3. When you compare this with the cost of similar commercial equipment, our hobby can be shown to be very economical. For instance, a comparable wah-wah would cost you about £15, and you would not receive the satisfaction of building your own. Oh, back again. It's back again. They really, really want to get rid of these. Oh, look at that. 4-station intercoms. Cut your 4-station intercoms. Read all about it. Oh, yeah, there's this... do something useful for a change. Interesting. Do it in your spare time and enjoy it, and perhaps you'll save yourself some money. The secret is to be practical about the way you spend your spare time. These practical magazines show you how every month these 6 popular titles are packed with fascinating and constructive projects. Full instructions for making your own furniture and fitments for the home, as well as electronic gadgets for home, car or hobby. See which practical can widen your range of interests. It's funny how everyday electronics is a practical electronics. So this is what confuses me. Everyday electronics, then there's practical electronics. Television, woodworking, practical woodworking, practical hi-fi and audio, and practical wireless. I wonder what's the difference between those. Somebody could possibly answer. Maybe it's just interesting that there's 2 under the same branch. And now we're at the end of it, and yeah, it's got the same. As you can see, these are from drastically different. This is last month's and this is this month's. Enjoyed this read from last week over on my Patreon, because I put these out a week. So if you want to see the next one, it's actually already out. It's over on my Patreon. So yeah, so there's another one after this already up. It goes up today. It says staggered by a week. But like in the last week's comments on this, this last one, DK Hyde said that they have this gauge. Robert Trumpeter has got all the parts to build one of these, and apparently I didn't read this in the last video. In the last video, that these are two plant pot bases. Turned around on either side and painted. So these, yeah, and then screwed together or riveted together or something. So yeah, just plant pot bases. But yeah, the last thing that he said was a couple of days ago. I am receiving all the transistors and we'll build it and show it to you all. So yeah, Robert, please let us know how you get on with that. That'd be awesome. And like I say, if you want to see the next release of this, it's on the Patreon already. So yeah, for all patrons from the $2 tiers up. So if you want to support this museum and the Museum of Everything Else channel, it won't every week might not be a magazine. It will be some things different, and like I said, ideas, and I'll be maybe a bit more prepared on the next magazine to whack together a breadboard or something. And I'm gonna go and check out these. Anyway, I've been Sam. This is the Museum of Everything Else, and yeah, don't forget to subscribe if you like these kind of things. Cheer for now.